I know the logs. Oh my gosh. This will be 5.4 because 5.2 was when we had it to the exponent and 5.3 was when it had an e in it. So it's basically the same thing just with e's, which is why we did 5.2 and 5.3 kind of smushed together. 5.4 is where we switched to doing log stuff. So we're not really doing anything new with it that you didn't do in Algebra 2. So it should hopefully be reviewed, but I also know logs are confusing and a little bit weird, and that's okay. So some important pieces we need to have are our common log, which is a log with a base of 10, and we just write it as log. Like you don't have a little number at the bottom. If it doesn't have a little number, it's a base of 10. And our natural log, which is log base e, so that's why the e is involved in this chapter, which we write as ln. And these are the only two that have buttons on the calculator, is the common log and the natural log. Everything else we have to be able to do either mentally or in terms of these two logs. These are the only logs that have buttons on the calculator. So the other piece we're going to really need to start this out is how we can switch between an exponential form of a statement and a logarithmic form, and why the heck we care. So our exponential form, that's when we have our base to some power equals an argument. Those are the letters we usually use. You may have done these with other letters. Now, some teachers do BPA log BAP. Others will do it as BEA and BAE. So however you choose to do it, I don't care what letters we use. But our exponential form, we have our base, our power, and the argument. And when we switch it to log form, that's when we're going to have our log base b, so little bitty baby number b, of a equals p. And we're going to start with this very bottom row stuff, switching between our exponential form and our logarithmic form. So this is how we're starting. And since we're just going to be switching forms, it's going to be really important that things are written correctly. So I'm going to give you guys a whole bunch of the equations that we're going to use today. Honestly, I doubt we're going to get all the way through the story problems, but I'm not going to cut them apart because I don't feel like it. So, yeah, story problems and these ones too. I know, I'm a party girl.
Oh no.
So we're going to start, the top two rows are going to be the first ones, and what we're going to do is switch them from logarithmic form to exponential form. And then the next two rows, we're going to switch from exponential form into logarithmic form. So we're just physically moving the pieces around. These two things are equivalent. The reason we have logs is so that we can get that p, the power, out of the exponent. Because when we have exponentials and it's 2 to the x, we don't want to have x as an exponent anymore. So to be able to solve it, we need to switch it around. So, does anyone need more time on this page? Okay. So this is the top two rows. And what we're going to do is we're going to rewrite these in exponential form. I have our two little statements. They're very tiny, but they're up here. Our BPA log BAP. And what we're going to do is we're going to figure out what is our base. There we go. Our base, which becomes the base of which is the base of our log. What's the power? And what's the argument? So we can move it around. So on this first one, what is our base? On this guy. 4. Our base is 4. So when we switch this around, we're going to have 4 at the bottom. What is the power? What is the p? -2. And Chase here. Chase. Oh, okay. Never mind. I got one there for you. So what is our argument then? What's the A piece? 1/16? And this is a true statement. 4 to the power of -2 is 1/16. It just is. So these two statements are equivalent. They mean the same thing. Same thing on the next one. I'm going to do the right.
What does P stand for?
Power. P is our power. A is our argument. B is the base. So on the next one, what is our base? 7. This guy over here. What is our power? 2. And what is our argument? 49. So when we write this in its exponential form, we have our base, which is 7, to the power of 2, which equals 49. How about on this next row? What are we going to get on this first one? 2 to the power of 0 equals 1. So our base to the power equals the argument. So our base to our power equals our argument. So we're going to have our not that pen. 2 to the power of 0 equals 1. Anything raised to a 0 power is 1. All right, last one on this side. Our last one going this direction. What are we going to wind up with on this last one? 3 to the what? To the third power equals 27. Okay? Vaguely familiar? It's been a minute, but just switching between them. We're just playing match them up and fluff them around. So then we're going to practice going the other direction. So those next 4 on there, we're going to take the exponential form and put them as logs. So going the other direction, we're still using those same pieces. We're going to take our, it's going to freeze, base and our power, which is purple, and our argument, and put it in our log form. So on this first one, what's our base? 5. What is our power? 3. And what's our argument? 125. So when we're writing it in log form, we're going to put log base 5 of 125 equals 3. Okay? Same Bob on the next one. What's our base? This one over here. 3. What's our power? Squared, power of 2. And our argument? 9. So we're going to have our log base 3 of 9 equals 2. Okay. Next one. How are we going to write the next one as a log? Log base 2 of 125 we have our log base 2 of 125 equals 5. All right, last one like this. How do we write this one? Log base e of y equals x. Log base e, that's one of our special ones though. So how else could I write log base e? ln, that's our natural log of y equals x. Okay? Vaguely familiar? We've seen it before?
Yes.
Okay, good. I'm going to give you some more properties, things that we need to remember. We've, again, seen them before, but I'm just going to give them to you in a list so that we can use them. Whoa, waiting. I got what we waited. Okay. So these are some special properties that we're going to wind up using. So any log with any base that has an argument of 1 is going to equal 0. Because any exponential with a power of 0 equals 1. So log base a to the 0 of 1. We'd write that as a to the power of 0. So it's, I'm confuddling my words here. If I wrote this top one in exponential form, we'd have our base of a, our power of 0, and our argument of, wrong color, there we go, 1. So this is the same thing as whatever we have as a base to some power of 0 equals 1. Anything raised to a 0 power is 1. Same thing on the next one. This is saying a very similar thing, is that any base raised to the power of 1 equals itself. So log base a of a is always going to equal 1. So if your base and your argument match, your exponent's 1. If you have an exponential inside, remember those are inverse functions, so if I have log base a of a to the something, they cancel each other out. Because logs and exponentials are inverses of each other. And then the last two are the same thing, just worded differently. It's just, we put the log inside the exponential instead of the exponential inside the log. And we're going to use those when we get into solving stuff. Okay, so you're going to want to have these. We're going to use them. Okay. You ready to change page?
No.
Not yet? Still writing? Okay, write it down. We're going to practice solving this a little bit. Oh, if I'm one? Okay. I will set.
We'll try it. No, I can't. It was just like I was
I've never had homework with you ever.
Yeah,
It was how well.
Yeah, I never got that.
My screen changed.
yeah, we graded them in.
All right.
In algebra, you have been like,
We're going to look at just a few of these. Evaluating without a calculator, because honestly, at this point, we don't know how to put it in the calculator. So what we're really asking here is to find the power. So if it helps, you can rewrite these as an equation where we have log base 2 of 1/16 equals some power. So 2 to what power equals 1/16? We know if it's negative, that's going to make it our fraction because our power, if it's negative, flips it. And 2 to the 4th is 16. So log base 2 of 1/16 is -4. Because that would make the statement true. So if you need to write them like this, you absolutely can. But we want to try and not have to do that every time. So if we look at this one over here, log base 12 of 144. Say this is asking us 12 to what power is 144? Squared. So 12 to the power of 2 is 144. So the next one, we don't have a base written there, so what's our base? 10. So 10 to what power? 3. Because our argument is going to be 3. Just be careful. I was careful thinking cube because it's not going to equal cube. It's going to equal 3. Because 10 cubed it does do it, but if it equals cube, that's going to be weird. It equals 3. Okay? I'm just saying, you're not wrong. You're just going to get stuck in your own head trying to make it equal cube. Okay? So for the next one, log base 4 of 1/64. 4 to what power is 64? -3. Okay? We're going to practice more with these tomorrow. We're going to be working with logs a bunch. Okay? So I'm going to put the homework up there. We're going to work more with it. We'll do those 2 stories tomorrow. So hang on to him. I just didn't feel like cutting him off while y'all were taking the quiz. So.
Oh, that's a lot of homework.
To be fair, you can do 1, 3, and 7, or what we did today, switching them between them.
Only 3?
I was going to say, I think there's another one like that, but I know for sure the first 3 are like that.
13, that's not one.
I mean, they do have a lot of ABCs.
So the homework's only like 40.
Again, you pick the questions. It took me 2 pages to do the 5.4.
I'm done.
Have a great rest of your day. 4 more wake-ups till Thanksgiving break. We can do 4 more wake-ups.